Scale factors of quadratic functions. So in addition to moving left and right, up and down, we can also scale this quadratic function. I can make it wider, I can make it narrower than the parent function, and that's what the a value does. So this a is what changes the width of our quadratic. So if your absolute value of a is greater than 1, so positive or negative, if a is a 2, a 3, a 4, anything larger than 1, it's called a vertical stretch. So what this does is it pulls the quadratic function away from the x-axis in a vertical direction. So it takes your blue, that's the original, and it takes these ends and it pulls this upward, and that's what creates a narrower parabola. We also have a vertical compression, is if the absolute value of a is less than 1. So again, positive or negative, doesn't matter. 1/2, 2/3, 1/4, anything smaller than 1. This pushes the graph towards the x-axis in a vertical direction, making the graph wider than the original. So this time you're going to take these ends and push towards the x-axis, making your graph fall wider away from the y-axis. The last transformation we have is a reflection over the x-axis. That only happens when a is negative. Doesn't matter what number, as long as a is negative, it reflects. So it takes this blue original and flips it over the x-axis. So let's look at some examples. Example 1 from equations. F of x equals x squared, that's the original, is transformed to create 2x squared. Describe the transformations. So this 2 is in my a spot, and since 2 is greater than 1, that means this had a vertical stretch by a factor of 2. Example 2, f of x equals x squared, that's the parent, transformed to be g of x equals 3/4 x squared. So again, this is your a because it's in the front and it's multiplied. Since 3/4 is less than 1, that means there was a vertical compression by, again, a factor of 3/4. Example 3, x squared is transformed to negative 3f of x. So this is in your function notation now because I have this f here, but it's still looking at a because this is still in the a spot. Now, there's really two things that are going on here. Yes, negative 3 is less than 1, but the negative does its own job. So since the number is a negative number, that means it was reflected across the x-axis. That's one transformation. So the negative is taken care of. Now we have to look at the number itself. Again, it doesn't matter if it's positive or negative. That's why we have the absolute value of a. So the 3 is greater than 1, so that means there was a vertical stretch by 3. So your graph is narrower than the original and it's reflected over the x-axis. Example 4, f of x equals x squared transformed to g of x equals 5/2 f of x. So again, this is function notation because we have the f of x. 5/2 is in the a spot. Now, just because it's a fraction does not mean it's a vertical compression. It doesn't mean it's automatically less than 1. 5/2 is actually 2.5, and that's greater than 1. So you have to be careful with your fractions. So this is actually a vertical stretch by 5/2. Now let's look at some graphs. Example 5. The graph of the quadratic parent function f of x and a transformed function g of x are shown on the grid below. Describe the transformations that will take f of x to g of x. So the obvious one is the reflection, because usually the parent function is facing up and this new function is facing down. That means it had to have been reflected across the x-axis. So that's one transformation. Now, we have to decide if there was a vertical stretch or a vertical compression. So I want you to look at a kind of like slope. So if we look at our parent function, the dashed, it starts at 0, 0, and it ends up at 1, 1. That means you went up 1 and right 1 to get to the next point. So our new function, if we look at the new one, we had to go, well, down. Again, we knew the reflection, but it didn't quite make it all the way to 1. So the parent function has a ratio of 1 to 1. The new function has 1 to like maybe what, 3/4 or so. So since I hit my graph here before I hit the 1 spot, that means that this graph is actually narrower. It fits inside my parent function. So since it's narrower, that means there was a vertical stretch. It's hard to find the actual factor off of a graph. Okay, you may hit that in Algebra 2. So for now, we just know that it's been vertically stretched. It's narrower than the original. Example 6. Describe the transformations from f of x to g of x. So again, the first thing I look for is a reflection, but my original function f is up, and so is my new function g is also facing up, so there was no reflection across the x-axis. Now, we have to decide, is this a vertical stretch or was it vertically compressed? So again, the original ratio from vertex to the first point is 1 and 1. So now we have to look at our new function. So from here, and then this is our first point. It's up 1, but I go way past my 1, so I'm further out from my original quadratic function. So that means this was vertically compressed. It's like you took this new function, or you took the old one and pushed it down towards the x-axis to get the new one. You compressed it down. Now let's look at writing equations. So example 7, what is the equation for the quadratic equation that has been vertically stretched by a factor of 3 from the quadratic parent function? So again, find where you're starting from. So in this case, it says from the parent function. So my parent is y equals x squared. Now, what are we doing to it? So it says I'm going to vertically stretch it by a factor of 3. So being vertically stretched, that's your a value. So it's going to be a times f of x. So a is what's multiplied to the front of my function. So my new function, let's call the new one g of x, is equal to 3, that's my a value, times my old function f of x. Well, the old function is this x squared piece. So this f of x gets replaced with x squared. So g of x equals 3x squared. And then there's nothing to simplify, so this is your new transformed function that takes the original x squared and stretches it by a factor of 3. Number 8. Given that f of x equals x squared plus 3, write the function g of x that has been vertically compressed by a factor of 1/3 from f of x. So again, find where you're starting from. It says from f of x, and that's this function here. So now we're not starting with the parent function. We're starting with f of x equals x squared plus 3. I'm going to write the function that has been vertically compressed by a factor of 1/3. So since it's vertically compressed, that's our a value. It looks like this, a times f of x. And our a, since it's compressed by a factor of 1/3, our a is equal to 1/3. So g of x, our new function, will be whatever a is times my old one. And we said that a was 1/3 times f of x. And so now what we're going to do is we're going to replace this f of x. Well, here's f of x. So x squared plus 3 is the old function. So that's going to go right here in this f of x spot. So we're going to have g of x equals 1/3 times everything, all of this, x squared plus 3. Now this I can simplify a little bit. I can take this 1/3 and I can distribute it in. So 1/3 times x squared is just 1/3 x squared. 1/3 times 3 makes 1. So my function that was vertically compressed by f of x is 1/3 x squared plus 1. 9. What is the equation for the quadratic parent function with the transformation -2/5 f of x? So to find where you're starting from, I got to figure out what f of x actually is. for the quadratic parent function with the transformation. So what I'm starting with is f of x equals x squared, because that's my parent function. Then I'm going to do this to it. I'm going to do negative 2/5 f of x. So my new function, g of x, is negative 2/5 f of x. So again, we're going to do some replacing. Take this f of x and replace it with what the old function was, which is just x squared. So g of x equals negative 2/5 times x squared. And since all I have is x squared, you don't even really need those parentheses. I don't have anything other than x squared. 10. What is the equation for the quadratic function that has been reflected over the x-axis and been vertically stretched by a factor of 4? So because it doesn't give me a function, it just says the quadratic function, we're going to assume that this is the parent. Since it doesn't give me another f of x, well, I gotta assume I gotta start somewhere. So it's the parent function. So now two things are actually happening. Number one, it's been reflected over the x-axis. That's the first thing. But it's also been vertically stretched by a factor of 4. So we have two things going on. Let's take them one at a time. So for the reflection, that means that you have a negative a value. Now, vertically stretched by a factor of 4, I'll do VS for vertically stretched. That means that your a is equal to a 4. So when you combine these two together, overall, you're going to have negative 4 f of x. Remember, the negative does one job and the number does another. The negative reflects, the number will either stretch or compress. So let's write our new function. G of x equals negative 4 f of x. Let's do our replacing. F of x gets replaced with whatever f of x was, which in this case is just x squared. So g of x equals negative 4 x squared.